Hi, welcome to 7.1, area of a region between two curves. So imagine you have a curve up on top, curve down below. That'd be like our integral of f of x minus g of x dx. Here's our f of x. Here's the curve describing g of x. This area is going to be the integral of the upper curve, so this is the area under the curve, minus the integral from a to b of g of x dx, the area under that curve. And that's the idea behind the region, the area of the region behind between two curves. So we can get a little more formal in the definition. If f and g are continuous on the interval from a to b, and g of x is less than f of x for all x in the interval, then the area of the region bounded by the graphs of f and g and the vertical line x equals a and x equals b is going to be the integral from a to b of f of x minus g of x dx. So example 1, set up the definite integral that gives the area of the region bounded by f of x equals x squared minus 4x plus 3. That would be this one. Here's our f of x. It's a parabola opening up, and g of x equals negative x squared plus 2x plus 3. This is g of x up here. It's the parabola opening down. So the first part says to set up the definite integral. So we need to find out where these two are going to be equal. What is this point? What is this point? We can probably guess where this is. Looks like it's 0, x being 0. This looks like 1, 2, probably 3. We're going to verify that though. So where is f of x equal to g of x? Well, f of x is defined by x squared minus 4x plus 3, and g of x is negative x squared plus 2x plus 3. Let's go and solve this, adding x squared to both sides, subtracting 2x, and then adding, or should I say subtracting 3. We have 2x squared minus 6x equals 0. From here we could factor out a 2x. We have x minus 3 equals 0. Setting each factor equal to 0, 2x equals 0, so x equals 0. X minus 3 equals 0, so x equals 3. So that our intuition was indeed good. X equals 0, and this would be 3 here. So we are looking at the integral from 0 to 3 of g of x, the upper curve, which is negative x squared plus 2x plus 3, minus f of x, the lower curve, which is going to be x squared minus 4x plus 3. I'm putting parentheses around this. We have to distribute this negative. So it's the integral from 0 to 3 of what? Negative x squared minus x squared is minus 2x squared. 2x minus negative 4x is plus 6x. 3 minus 3 is 0. So there is the integral we had to set up. That was the first part. Set up the integral. The next part is to evaluate the integral, find the area between the curves. So here we have the integral from 0 to 3 of negative 2x squared plus 6x dx. That's going to be negative 2x cubed over 3 plus 6x squared over 2 from 0 to 3. So we're looking at negative 2/3 times 3 squared cubed plus 6 divided by 2 is 3. 3 times 3 squared minus, if you put 0 in for either of these, you're going to get 0. So we have negative 2/3 times 27 plus 27. Let's see, 27 and 3, that's 9. Negative 2 times 9 is negative 18, plus 27 is 9. So the area between the curves here is 9. free to pause that one. We're going to go on to another. Okay, the integrand of the definite integral is a difference between two functions. So we're going to sketch the graph of each function and shade the region whose area is represented by the integral. What are we looking at here? We have 1 minus x squared, from negative 1 to 1, 1 minus x squared minus x squared minus 1. That's going to be a parabola opening down. There we go. So we have an integral opening, or a parabola opening down. And then we have another one which is defined to be x squared minus 1. That's a parabola opening up. So we want the area between them. I only have one other color with me, which is black, so I guess I'll shade this with black. Here. So that is the area we're discussing. We're also going to evaluate this. So we're looking at the integral from negative 1 to 1. 1 minus negative 1 is 2. Then negative x squared minus x squared is minus 2x squared. It's going to be 2x minus 2x cubed over 3 from negative 1 to 1. Probably could have done from, made it the integral 2 times the integral from 0 to 1 because it's an even function, but we're here, we'll continue. So it's 2 times 1 minus 2 times 1 cubed over 3 minus 2 times negative 1 minus 2 times negative 1 cubed over 3. That's 2 minus 2/3 plus 2 minus 2/3. 4 minus 4/3, that would be 12/3 minus 4/3 is 8/3. That's the area between the two curves. Okay, I'm going to move on here. Feel free to pause. Now, integration as an accumulation process. In this section, the integration for the area between two curves was developed by using a rectangle as a representative element. So we want to see a little visual of that. So here's your I should say, here's like f of x. This might be g of x. You'd have an approximating rectangle, and that's going to be going from A to B. For each new application in the remaining sections of this chapter, an appropriate representative element will be constructed using pre-calculus formulas you already know. And each integration formula will then be obtained by summing or accumulating these representative elements. So we take the known pre-calculus formula, use a representative element, and then we get the new integration formula. For example, for area, area is height times width. Height times width, that's the area of a rectangle. The change in area is going to be f of x minus g of x delta x. And the integration formula is integral from a to b of f of x minus g of x dx. Okay. Example 3. Find the area of the region by integrating. So, with respect to x and with respect to y. So in the first case, this is what we're most used to seeing. That'd be our representative rectangle. First, x squared equals 6 minus x. We've got to solve, find these places of intersection. Is that right here? Let's find out. That means x squared plus 6 or plus x minus 6 equals 0. So that means x plus 3 times x minus 2 equals 0. That means x plus 3 is 0, x equals negative 3, x minus 2 is 0, x equals 2. So those were indeed very good guesses there. Now, our upper curve is the line 6 minus x. So we're looking at the area, or the integral from negative 3 to 2 of our upper curve, 6 minus x, minus the lower curve, which is x squared. That's going to be 6x minus x squared over 2 minus x cubed over 3 from negative 3 to 2. That's 6 times 2 minus 2 squared over 2 minus 2 cubed over 3 minus quantity 6 times negative 3 minus negative 3 squared over 2 minus negative 3 cubed over 3. That's 12. Okay, we have 4 over 2 is 2, so minus 2. Then we have 8/3, so minus 8/3. We have minus 6 times negative 3 is, that's a negative 18, so minus a negative is plus 18. Minus a negative of a negative, well, actually that's not going to be negative. Negative 3 squared is 9, so minus negative 9 halves, so plus 9 halves. And we have minus a negative of a negative, so it stays negative. That's 27/3 or 9. Okay, so let's see what we have here. 12 plus 18 is 30. 30 minus 2 is 28, minus another 9 is 19. Then we have minus 8/3 plus 9 halves. That's going to be 16/6 plus 27/6. 19. Okay, negative 16 plus 27 is 11/6 plus 11/6. That's going to be 19 and plus 1 and 5/6, so it looks like it's 20 and 5/6. So that's the area. Now that was integrating with respect to x. Do you think it'll be any different if we integrate with respect to y? If we go with respect to y, we have a different rectangle. With respect to y, we're doing this. And this is interesting because if we go with respect to y, we have the one on the right versus the one on the left. This changes at this point right here. 2, looks like that's 4. At 4 changes, and then you have this curve here and here. Now, in integrating with respect to y, we have to do a little bit of algebra first. So let me go ahead and erase what we have here. Then we're going to do the y portion. So I'll step out of the way. If this is a good time to pause, to write some stuff down, go ahead and do that. Okay, I'm going to go ahead and go. Now we're integrating with respect to y. First thing we have to do is come up with these equations, solve them for x. So we have y equals x squared. Well, if we take the square root of both sides, since we're solving for x, we have to remember to do plus or minus for the y part. So x would be the positive square root of y, and x equals the negative square root of y. That comes into play here. This part right here, this is the square root of y. Over here is the negative square root of y. And then we have y equals 6 minus x. If we subtract 6 from both sides, y minus 6 equals negative x. Divided by a negative 1, 6 minus y equals x. So this equation here would be 6 minus y. So we have to look at this point of intersection down to this line here. This horizontal line is where our upper curve changes from 6 minus y to the square root of y. And then we're going to go from that point to 0, or we can say 0 to 4, and 4 to up here. What's this one going to be? Well, this occurs whenever x is negative 3. We know y equals x squared, y equals negative 3 squared, so y equals 9. So we have two regions to discuss. We'll have the integral. So here we're looking at integral from a to b of the right curve minus the left curve. Say dy. So we have the integral from 0 to 4. On the right side here, we have the square root of y. On the left side, we have the negative square root of y. Plus the integral from 4 to 9 of 6 minus y minus the negative square root of y. So 6 minus y is this one here. Negative square root of y is this part there. Okay. So we have the integral from 0 to 4. This becomes 2 times the square root of y dy plus integral from 4 to 9 of 6 minus y plus the square root of y dy. Now the antiderivative of the square root of y is going to be 2 times y to the 3 halves divided by 3 halves, and that's going from 0 to 4. Then plus, this antiderivative will be 6 minus y squared over 2 plus y to the 3 halves over 3 halves. And this is from 4 to 9. Okay. Doing the math here, this is 4/3 times what? 4 to the 3 halves minus 0 to the 3 halves. And we have plus, this should have been a 6y. Okay. That's 6 times 9 minus 9 squared over 2 plus 2/3 times 9 to the 3 halves. Can you see this over here? Okay. Then minus, I don't need this parenthesis here. Minus what? I'm going to put 4 in there for the y's. 6 times 4 minus 4 squared over 2 plus 2/3 times 4 to the 3 halves. let's finalize all this. Square root of 4 is 2. 2 cubed is 8. So we have 4/3 times 8 is 32/3. Thank you. Plus 6 times 9 is 54. Minus 81 halves. Plus, I'm looking over there, 9 to the 3 halves. Square root of 9 is 3. 3 cubed is 27. 27 divided by 3 is 9. 2 times 9 is 18. We have a minus 24. So minus 24 minus negative makes it plus. 16 over 2 is 8. And then let's see, the square root of 4 is 2. 2 cubed is 8. Times 2/3 is 16/3. So minus 16/3. Okay. All this comes out to be, again, 20 and 5/6. Same answer. Okay. So that would be integrating with respect to y. And so notice how the rectangle changed for that. I'll step out of the way here for you. Come over there. So again, feel free to pause on this. So we go on to example 4. Okay, sketch the region bounded by the graphs of the algebraic functions and find the area of the region. So f of x equals x squared plus 2x plus 1, and g of x equals 3x plus 3. We have this parabola. It doesn't matter, this part's in the dark because we're looking at 3x plus 3. So it's not drawn to scale. Please be forgiving on that. Here's our g of x. Actually, I'm sorry, this does go through this x-intercept. So, which is going to be a problem because my graph there. So we're looking at this region. Let's draw ourselves an approximating rectangle. Here's our f of x. So we're looking at the integral of g of x, which is 3x plus 3 minus f of x, which is x squared plus 2x plus 1. And don't forget these parentheses because it'll make a big difference if you didn't have the negatives distributed properly. Now, where are they intersecting? I think we see they coincide at -1. Where else do they coincide? Well, that's where we could say x squared plus 2x plus 1 equals 3x plus 3. So we can subtract 3x, subtract 3, and x squared minus x minus 2 equals 0. That would factor to be x minus 2 times x plus 1. So x equals 2 or -1. And this must be occurring at 2. We're going to go -1 to 2. So now just do the math again. Just going to distribute the negative and simplify our expression inside and then integrate. -1 to 2. Let's see, we have -x squared, 3x minus 2x, which is plus x. 3 minus 1 is plus 2. That's going to be -x cubed over 3 plus x squared over 2 plus 2x from -1 to 2. So it's -2 being, the negative of 2 being cubed over 3 plus 2 squared over 2 plus 2 times 2 minus negative of -1 cubed over 3 plus negative 1 squared over 2 plus 2 times negative 1.